Write this. I think it's a bit blur, but I think you can read this. W is the amount of work done by the system, and Q is the amount of heat supplied to the system. Choose the correct option for the change in the internal energy and the type of system from the given options respectively. Okay, Hiba. You all can send the answer on my on the Zoom chat itself. Okay. Okay, Devangi. हीट भी तो चेंज हो रहा है ना यहाँ पे. There is an exchange of heat also going on, na? देखिए, सबसे पहले तो डेल्टा यू में आपके पास both are things are there, right? Q and W also. अब ये बताइए, first of all, Q is the amount of heat supplied to the system. 2 का वर्ड आ गया, यानी कि heat will be positive. W is the amount of work done by the system आ गया, यानी कि this will be negative, है ना? System is doing the work, so it will be negative. So Q positive is here and W negative is here. Okay, and obviously it is going to be a closed system because if you are going to give it heat, open system में आप अगर heat कीजिएगा तो heat तो बाहर निकल जाएगा. Okay, so you can give heat and heat will be there only if you have a closed system. Okay, so there are only two things happening. आपने यहाँ पे देखिए, heat is supplied to the system and there is no heat that is going out of the system. वो कह रहे हैं ना, क्योंकि सिर्फ supply हो रहा है. If they are also telling you heat is also going out of the system, that means वहाँ पे आपके पास open system हो सकता है, right? But this will be delta U is equal to Q minus W, that is a closed system. C is the correct option. Right, next. Pressure volume work. Okay, this is an important concept. How you can get the value of work using pressure and volumes. Okay, using pressure and volumes. Let us suppose again, we are going to take that example of a piston. This is your movable piston. Okay, this is your movable piston. There are gas molecules here. Now these gas molecules will be exerting pressure on the piston like this. And there will be a pressure that is exerted by the atmosphere here. Okay? So there are two pressures. Once, whenever you have some piston, if the piston is not moving, that means we have an equilibrium. And in equilibrium, the external pressure and the internal pressure are equal. Okay? So at this case, what is happening? P external is equal to P internal. Achha. If I have a case in which P external is greater than P internal, तो क्या होगा बताइए? Piston will move up or down. Tell me what is going to happen here, guys. प्लीज जल्दी जल्दी आंसर कीजिए, बहुत आसान सवाल पूछते हैं, है ना? आप लोग बहुत ज्यादा टाइम लगाते हैं. देवांगी, इरम, फहद, हिबा, जानिया, अब्दुल्ला, प्लीज टेल मी. If the external pressure is high than the internal pressure, then piston will move up या down?
Down.
ठीक है. Piston moves down. Okay. When the piston will move down, then the volume will also change. Yes or no? Please tell me, guys. Correct?
Yes, sir.
As piston moves, volume will change. Let us suppose the new piston, it came here. Okay, it came here. So this is the distance it moved. Yes or no? Please tell me, guys. This is the L length it moved, correct? And this is not going to be a 2D thing. या आप मान लीजिए this will be a cylindrical type of thing. ठीक है? Cylindrical हो या फिर कुछ भी हो. So piston will also be like a cylindrical thing. Now, the volume change that we have, the delta V that we are going to see, this will be equal to the length into the area of the piston. Is that right? Yes or no? Tell me, guys. Can I write this? Because what is volume? If I talk about a cube, तो cube का volume क्या होता है? वो the area of the base is a square and the length is a, है ना? तो area of the base into the length, that is equal to a cube. Similarly, the area of the base, that is equal to a, and the length it moves, that is equal to L. Clear, guys? Yes or no? Please tell me. Delta V will be equal to L into A. Yes, Jania, Hiba, Abdullah, please tell me. Is this clear? How change in volume will be equal to length into area?
Yes.
Yes? Okay. Now, and what is pressure? Pressure is equal to force upon area. Pressure is equal to force upon area. Okay. And what is work? Since we are going to define work, work is equal to force into the distance. Force into the distance. Now, force I can write it as, force can be written as pressure into area. Is that right? And distance can be the length. Clear hai? Yes or no? Please tell me, guys.
Yes, sir.
ठीक है? अच्छा. Now, I can write work will be equal to A into L is equal to delta V into the pressure. और pressure कहाँ पे? External pressure. ठीक है? Delta V. अच्छा, एक बात बताइए. V final बड़ा होगा या V initial बड़ा होगा? Tell me, guys. Which will be greater?
Initial.
V initial आपका बड़ा होगा, right? V final नहीं होगा, V initial बड़ा होगा. और अगर V initial बड़ा होगा तो V final minus V initial क्या आ जाएगा आपके पास? नेगेटिव आ जाएगा. Is that right? Yes or no? Correct? V final minus V initial negative आ जाएगा, तो that means your delta change in volume will be negative. लेकिन change in volume को हमको हमेशा positive ही रखना है. Okay? You have to keep this always what? You have to keep this positive. So we'll put a negative sign outside the work here to get what? To get the positive work. Is that clear? Yes or no? Tell me, guys. Delta V, we are going to change will always be positive ना, तो इस वजह से negative sign यहाँ पे लगा दिया. That is going to keep the work always, sorry, the change in volume always positive. ठीक है? So see here. वर्क का आपके पास क्या फॉर्मूला है, माइनस पी एक्सटर्नल इंटू डेल्टा वी, ठीक है। नाउ डेल्टा वी इफ इट इज गोइंग टू बी पॉजिटिव, वर्क आपका अगर पॉजिटिव होगा तो पिस्टन फाइनल माइनस वी इनिशियल आपका नेगेटिव होना चाहिए, ठीक है। एंड अगर आपके पास वर्क नेगेटिव आया तो वो पिस्टन के लिए वर्क फाइनल माइनस वी इनिशियल पॉजिटिव होना चाहिए, राइट। व्हेन वी फाइनल माइनस वी इनिशियल इज नेगेटिव तो वर्क क्या हो जाएगा, पॉजिटिव। एंड व्हेन वी फाइनल माइनस वी इनिशियल इज पॉजिटिव, ठीक है, तो ये पॉजिटिव हो जाएगा तो वर्क नेगेटिव हो जाएगा। नाउ व्हाट विल बी द मूवमेंट ऑफ पिस्टन हियर, फाइनल माइनस इनिशियल इज इक्वल टू व्हाट, फाइनल माइनस इनिशियल इज इक्वल टू नेगेटिव, यानी कि पिस्टन मूव्स डाउन, पिस्टन मूव्स डाउन यानी कि वर्क डन बाय, वर्क डन बाय नहीं होगा, वर्क डन ऑन सिस्टम हो जाएगा, राइट। यूजर इज नॉट वर्किंग, piston moves down, hence work done on system. When V final is greater than V initial, then only it will be what? Positive. V final minus V initial will be positive when V final is greater. That means piston moves up. और जब piston up move करेगा, that means work done by system. Work done जब by system होगा तो ये negative ही होना चाहिए, and work done on system होगा तो ये positive ही होना चाहिए. So is this formula clear to you guys? Work will be equal to minus P external into delta V. ठीक है, and why we have got the minus sign there? We have got minus sign there so that the change in volume will always be positive. ठीक है, change in volume को हम लोग positive लेके चल रहे हैं, इस वजह से it is going to be work done is equal to minus P external into delta V. Write this down. Let me know if you have any doubts. Okay, if you remember, this is the case that we have taken. Work is done, or what type of work is this? This is going to be your irreversible work. Okay, this is irreversible change because हमने क्या किया? Imagine that we have just added the complete sand bag. Okay, we have poured down the complete bag of sand, and we have seen a change in the volume. Okay, so we have written delta V. We are going to look at the we are going to look at the reversible change. This is irreversible. We are going to look at the reversible work done. And in that case, we will take a small volume change and then we will integrate over it. Okay, so please write this down. Done, guys? All of you wrote this? Anyone still writing? Please let me know. Okay, everyone done? Okay, write a question. Oops. A gas absorbs 120 joules of heat and expands against external pressure of 1.10 atm from a volume of 500 ml to 2 liters. What is the change? In internal energy. So there are two things happening here. एक सिस्टम है आपके पास, उस सिस्टम में you are giving in heat, and because of that heat, system expands and does work. ठीक है? And what does it do? It does work here. Now, delta U is equal to Q plus W. ठीक है? तो Q तो आपको दिख रहा है that it is going to be 120 joules. We have to calculate the W here. Now, we have just seen W in this case is equal to what minus P external into change in volume. Now, right here, the P external minus 1.10 ATM into delta V will be always V final minus V initial. So V final is equal to how much? 500 ml to 2 liters. Now, if I talk about liters, it is going to be 2 minus 0.5 liters. And this is going to be equal to minus 1.10 into 1.5 liter ATM. Okay. And 1 liter ATM is equal to 1 joule. Remember this conversion? 1 liter ATM is equal to 1 joule. Calculate this. 15 into 11 and then 1, 2, 3. This is 101.3 joules. Calculate this and tell me. Just a second. This will be 1 point. A second. This is 1 liter ATM. इसको आप बता दीजिए please. 1 liter ATM is equal to somewhere around 100 joules. Not. Just a second. First of all, calculate this. 1.10 into 1.5 will be equal to 0.167. है ना? 0.167. That to minus liter ATM. Okay. And right here, 1 liter ATM approximately equal to 100 joule, and it is exactly equal to 101.3 joules. So ये आपका हो जाएगा minus 0.167. One 165. So somewhere around आपके पास 1 point joules आ जाएगा. 16.5 joules आ जाएगा आपके पास. 16 ना? हाँ 16. I've just multiplied by 100, not 101.3. Did I do another mistake? Okay. This is 1.65. My bad, guys. 1.65 liter ATM. This will be 1.65 into 10 to the 101.3. अब ये joules हो जाएगा. This will be equal to 165 joules. 5 and delta U कितना हो जाएगा? Delta U will be equal to Q plus minus sign Q plus W, and since work is done by the system, Q was 120, no? 120 minus 165. Those who are having a bit of difficulty, this will be 120 plus minus 165 joules. 120 minus 165 joules. This will be equal to minus 45 joules. This will be the change in internal energy. After this, we will write the topic reversible work. Okay, in reversible work, we will look at the case in which we were putting 1 grain of a sand at a time. And slowly, we were increasing the external pressure. Now, in this case, please write the displacement of piston that will take place. Displacement of piston. This will be equal to DL, small length. And there will be a small change in the volume. So dV change will be there. Now the area of the piston is the same. That is multiplied by the small change in the length. Pressure is equal to force upon area. That means force is equal to pressure into area. And the small work that will be done, it will be equal to force into the small distance. Force is equal to pressure into area into small distance. And we can write this as dW is equal to minus P external into A into DL will be equal to dV. Okay, so here also we are getting the same thing in terms of P external. Now we can integrate both sides to get the work done. This is the small work, is right? Integrate both sides. Integration of D into W will be equal to the integration of minus P external into the small change in volume. How many of you are completely unfamiliar with integration? Raise your hand. Completely. Okay, all of you have some familiarity with integration. Physics you have done, right? Devangi, Iram, Fahad, Hiba, Janya, tell me.
Yes, sir.
है ना? ठीक है. Now, here dW will be equal to W. Okay, because here we have W to the power of 0 and we will get W to the power of 1. So this will be V and we'll write it reversible because we are talking about the work done in reversible process. Minus P external is a constant. So minus P external will go outside. We'll have the integration of dV, small volume, and the volume change is from V initial to V final. Okay, and this will be equal to again minus P external. dV does not have any other variable here. So we have V to the power of 0 and we'll get V to the power of 1. So we'll get here V from V final and V initial. And this will be equal to minus P external V final minus V initial, which I can write it as minus P external into delta V. This is also the work done in reversible process. It is still the same, but in reversible process, since you know that very small change is taking place, so we'll calculate also in terms of P internal. You have seen about P external, we'll calculate in terms of P internal. Please write next. In terms of P internal. Okay, because we cannot always detect the change of P external. ना यहाँ पे आप देखिए, आप ऐसा कर सकते हैं कि you have a small gas chamber here, and if you are just putting one sand at a time, it is very difficult to measure the pressure change here. तो हम लोग क्या करेंगे, एक मैनोमीटर आप यहाँ पे लगा दीजिए, anything that can measure the pressure of internal system here, and you can detect the P internal always. So we need a formula in which we are having P internal in the term of work that is being done rather than P external. Okay, so P external का तो आप लोगों को पता चल जाएगा because you have the mass and everything there, and you are going to put it on the complete. You are going to put it on the complete piston. But in case when you are adding one green, we cannot calculate the pressure that is applied by one green. That is why we are going to use P internal. Right, next point, in terms of P internal. Okay, so why we are having P internal in the case of reversible? Because the change that is being done by P external with one grain of sand, it is very little and we cannot detect it. So we are going to detect with whatever change is there in the P internal. Okay, please write in terms of P internal. So see here, this is my piston. Okay, initially P internal was equal to P external. ठीक है, अब हमने एक यहाँ पे grain of sand डाल दिया. I added one grain of sand. Now initially आपके पास P internal और external same था, अब external ज्यादा हो चुका है. External is greater than P internal and by a very small amount. So now the new P external will be equal to P internal plus delta P that is added by one grain of salt. Okay, dP, that is small pressure that is added because of this one grain of salt. Now we have P external, P internal plus dP, और इसी चीज को हम लोग वहां पे we'll put this in that formula. We have got dW is equal to minus P external into dV. ठीक है, और इस P external में we'll put this formula here. We'll integrate dW is equal to integration of minus P internal plus dP into dV. Okay, and we will get minus outside integration of P internal into dV minus plus into minus minus dP into dV. Okay, so the integration of this complete thing and the integration of this thing also. Acha, this dP is a small pressure and dV is what? It is also a very small volume. So we can neglect this thing in comparison to this P internal into dV. Okay, in comparison to this, we can 1 rupee, you can never neglect 1 rupees. But if you have 1,00,000 rupees, then you can neglect this 1 rupees. Okay, so the same thing, we have P internal into the dV. That is why we can neglect the part where we have dP into dV. So this will be neglected. We will neglect this, and we have integration of dV, that is your W reversible is equal to minus the integration of P internal into the small change in volume. Now, there's a formula from the states of matter chapter that pressure is equal to the number PV is equal to nRT. Okay, pressure into volume is equal to the number of moles inside the system and the temperature inside the system. So we can write pressure is equal to nRT upon volume. So we have minus the integration of nRT, R is a constant, upon volume into dV. This will be equal to nRT is a constant because inside the system we are not adding anything, nor we are subtracting, we are just putting in some pressure. So nRT minus nRT will be outside. Minus nRT is outside, and you have integration of 1 upon V into dV. Okay. So the integration of the integration of 1 upon V is ln minus nRT ln V, log of V, and in square brackets you have V final, V initial लिख लीजिए या फिर V2 minus V1. V initial था V1 and V2 is the V final. Now you can plug this in nRT integration of V2 minus V1. Sorry guys, ln V2 minus ln V1. ln V2 minus ln V1. After this, see, there is again a formula in which we write ln A upon B as ln A minus ln B. So we can write ln V2 minus ln V1 as ln V2 upon V1. So minus nRT ln V2 upon V1. Okay. And ln is natural log. When you have log with a base of e, in order to change this to log with a base of 10, log e is equal to 2.303 into log 10. Log e is equal to 2.303 log 10. So we can write this as minus nRT. Wait a second. 2.303 into nRT कर देते हैं. Minus 2.303 nRT log with base 10 V2 upon V1. This is the W reversible. Write this down. Also write. See, if I have pressure 1, volume 1, so will be equal to number of moles in the first, that means the initial case, R and T1. ठीक है. उसी तरह से आपके पास फाइनल फेज में होगा P2 V2 is equal to N2 R T2. Okay, N2 R T2. लेकिन यहाँ पे एक बात देखिए, the number of moles and the temperature is not going to change. ठीक है, number of moles and the temperature is not going to change. तो आपके पास ये भी constant, temperature भी constant. Okay, and here you have this N and T are going to be constant in this case. अच्छा, यानी कि हम एक बात लिख सकते हैं, P1 V1 will be equal to P2 V2. Okay, so I can also write P1 upon P2 will be equal to V2 upon V1. Okay, P2 here and V1 here, and then we can plug in this part also. W reversible is equal to minus 2.303 nRT log of base 10. Rather than V2 upon V1, we can write P1 upon P2. Okay, so these are the two formulas that you can write. Because obviously pressure आपके पास measure करना आसान है. Internal pressure आप measure कर लीजिए initial phase में और final phase में, and then you can have the W reversible. Please write this down, guys.
तो पिछले वाले में प्रेशर को कांस्टेंट लिया और इसमें वेरिएबल ऐसे लिया.
वो एक्सटर्नल प्रेशर था ना, वो एक बार चेंज हो गया, राइट? यहाँ पे धीरे धीरे चेंज हो रहा है. एंड एट द एंड यहाँ पे भी आपके पास दो प्रेशर आएंगे, इंटरनल मतलब इनिशियल इंटरनल प्रेशर और फाइनल इंटरनल प्रेशर। Done, guys? Yes or no? Can we move on?
Yes, sir.
Okay. Now, related to this, there is a process which is known as isothermal expansion. Okay. Please see. Let's take two cases. In one case, we have a completely closed box like this. Okay. And here we have gas particles. Okay. And when you are going to heat this, thing, and it is completely closed off. So whatever the heat you are providing, it is going to get into the molecules, and then molecules will start to vibrate furiously. And as soon as they start vibrating furiously, what is going to happen? The temperature is going to increase. But if I have another case in which I have a piston of some sort, and I heat this. Now, the energy of the molecules here, it is going to increase, obviously. And they start hitting the walls. Okay. But right now the wall, this is a flexible wall, and they can lift this up. Okay. So they will lift it up. So what is happening? Their temperature is not increasing. Their energy is increasing, and they are using the same energy. They are using the same energy to lift the piston up. And if they are lifting the piston up, the temperature is going to be constant. Okay. And piston goes up. So if the piston goes up, that means there is an increase in volume. That means there is an expansion. And the temperature is constant, and that is why it is what? Isothermal. So whenever you read this word isothermal expansion, you will imagine this case. कि आप heat कर रहे हैं और उसके बाद that the molecules, these are lifting the piston up. Okay, so this is isothermal expansion. And whenever you have isothermal expansion, the temperature will be constant, and in those cases only you can use this thing. If it is reversible या reversible जो भी दिया रहे हैं आपके पास, if it is irreversible, then you can use this, right? If it is reversible, then you can use the previous one. ठीक है? Now write a question. Two liter of an ideal gas. 2 liter of an ideal gas at a pressure of 10 atm expands isothermally at external pressure of 1 atm. How much heat is absorbed by the system? Is absorbed by the system how much heat is absorbed by the system and how much work is done by the system if the gas expands to 10 liters. You see this question? Now here what is happening? Isothermal expansion. यानी कि आप क्या imagine कीजिएगा, आपके पास ऐसे you have a movable piston, you have this thing and you are providing it heat and heat is lifting the piston up. Okay, so these things you are going to imagine here. Okay. Now, अच्छा एक और चीज please remember here, whatever heat you are providing, okay, whatever heat you are providing, that is being used to lift the piston up. तो वहां पे आपके पास क्या होता है? In these cases, internal energy is not going to change. देखिए, आपने what happened here? You gave the system Q amount of heat, and the system used the same heat to do the work. So when the system does the work, it is equal to minus W, and you can write W is equal to what? Minus Q. Okay, so these equations are valid, and delta U will be equal to what? The change in internal energy will be equal to 0 in these cases when you have isothermal expansion. Why? Because whatever energy you are giving, the same energy system is utilizing, system is using the same energy in order to do work. So you're giving in through heat and system is losing the energy through work. Okay. That's another thing, but we'll write W is equal to minus. There is no sign of reversible nature, or we know that reversible is what it is imaginary. आपको theoretical में सवालों में दिया जाएगा. If it is not mentioned, then all of the process that we are going to look at, it is going to be irreversible process. So we can write minus P external into delta V. Now, P external is equal to what? 1 atm minus 1 atm. Delta V is equal to what? Final minus initial. Final is 10 liter. Initial is 2 liters. And we have got minus 1 into 8 liter atms. This will be equal to minus 8 into 101.3 joules. Okay. So I'm just approximating this to be as 800 joules of work. Is that clear? Yes or no? Please tell me, guys. 800 joules of work is done by the system. And what we have seen, Q is equal to minus W. That means minus 800 joules. Q is equal to minus W. Actually, this is minus W. Minus 800 यहाँ पे होगा, my bad. Q is equal to minus W. So minus, and what's the value of W? Minus 800 joules. So this will be equal to plus 800 joules. So we gave in heat of how much? 800 joules. And the work done by the system was 800 joules also. Okay. So this was minus 800 because work was done, and this was plus 800 joules because heat was given to the system. So this is how you calculate how much heat is absorbed, 800, and how much work is done by the system, minus 800, and heat is absorbed plus 800. Got it, guys? Yes or no? Tell me. Okay,
Yes,
this is
sir.
important. Okay, this is important. इसको समझिएगा. Isothermal expansion में Q is equal to minus W or W is equal to minus Q. There's another question that you can write. How much heat is absorbed and how much work is done if gas expands to vacuum? If gas expands to vacuum, इसी केस में आपके पास vacuum expand कर रहा है लेकिन gas. Now the important thing about this question is this word vacuum. Please write here, in vacuum P external is equal to 0. ठीक है, P external is equal to 0. तो उसी केस में W will be equal to what? Minus P external into delta V. So that is why the work will be done is equal to what? Work will be 0. And if work is equal to 0, then this will be also equal to Q. Okay, so in this case, W and Q, it is equal to 0. Okay, whenever you are expanding in vacuum में आपके पास expansion में, it does not require any work, it is going to be 0. And the heat absorbed will be also equal to 0. Okay, and when you have expansion of gas in vacuum, when the external pressure is equal to 0, it is known as free expansion. It is known as free expansion. Please write here a point. Expansion of gas at P external is equal to 0 is also called free expansion. Work done in free expansion is always 0. ठीक है, इसी में आपके पास same conditions. The question here is how much heat is absorbed, and how much work is done if the expansion takes place reversibly. Takes place reversibly. Okay, so again, it was what? It was isothermal expansion. So isothermal expansion में delta U will be equal to what? 0, and Q will be equal to minus of W. And in this case, it is reversible. So this will be equal to minus of W reversible is minus 2.303 nRT log V2 upon V1. Okay, because we have been given volume, so हम V2 upon V1 लिखेंगे. Okay, next thing, this will be 2.303 nRT log V2 upon V1. अच्छा, अब एक चीज आपको याद होगा, that inside this gas, whatever it has been given, you were not given in this case the number of moles and also the temperature. ठीक है, दोनों चीज हमारे पास यहाँ पे नहीं थी. Now what do we have here? We had the pressure and we had the volume. Is that right? Yes or no? Tell me, guys. We had these two things. Yes or no?
Yes, sir.
है ना, प्रेशर और हमारे पास वॉल्यूम था. So what was the initial pressure and initial volume? You had 2 liters of ideal gas, but that was the volume, and in 10 atm. Okay, and we know that PV is equal to what? nRT. Now since PV is equal to nRT, I can write 2.303. nRT को हम क्या लिख सकते हैं? PV, and this is initial pressure, initial volume. Okay, log of V2 upon V1. 2.303. The initial pressure is 10 atm. Volume is 2 liters. Log of V2 is how much? It expands to 10 liters. V1 is 2 liters. So you can cancel these two and you will get what? 5. This is equal to 2.303. 10 to the 20 into log of 5 liter atm. 2.303 into 20. The value of log 5 is 0.7 liter atm. So लीटर एटीएम को हटा के हम 100 जूल्स भी कर देते हैं. ठीक है, लीटर एटीएम इज इक्वल टू 100 जूल्स. सो दिस विल बी इक्वल टू हाउ मच? 2.303 70 into 2. 70 होगा, हाँ 70 हो जाएगा, into 20 है 14 and 2 more zeros and joules. कितना जाएगा आप ये? 14 into 2.3. This will be equal to 3224. This is the work in reversible. Okay, and what was the irreversible work? What was the irreversible work we got? Irreversible work was how much? नहीं, वर्क नहीं है आपके पास. This is minus of work. That was equal to Q. This is 3224.2. So वर्क की अगर बात करें तो it will be minus 3224.2 joules, and जो irreversible work था हमारे पास, that was equal to minus 800 joules. Okay, so minus sign just tells you whether it is the work done by the system or on the system. लेकिन system ने यहाँ पे in the reversible manner it did 3224 joules of work, somewhere around 300 joules of work, and here it did only 800 joules of work. Okay, so in this case we can write maximum work is done reversible process. In reversible process, you will always have the maximum work. Okay, it will always be greater than the irreversible work. Please write this down. And then we can write some conclusions here. Okay. The first law of thermodynamics is inherently very small in itself. Delta U is equal to Q plus W. But as you go on, the specific cases become a bit complex here. Okay. So we'll just summarize everything now. whatever we have learned till now regarding this first law of thermodynamics, delta U is equal to Q plus W. Done all of you? सबने लिख लिया? Is everyone done?
Yes,
Anyone
sir.
still writing? Done? Right, next. You have seen that delta U is equal to Q plus W. And we have also seen W is equal to minus P external into change in the volume. Okay, change in the volume. Now, if you have different processes, for example, if you have isothermal process, that is isothermal expansion. In isothermal expansion, the temperature is constant, right? So delta T will be equal to what? Actually, if you have T is constant, so delta T is equal to 0. Change in internal energy is also equal to 0. Change in internal energy, take a U, is also equal to 0, and Q is equal to minus of W. ठीक है, Q is equal to minus of W, whatever the value of W. ठीक है ना, minus W ऐसा नहीं कि आप यहाँ पे minus of W ये लिखिएगा, W पॉजिटिव भी हो सकता है यहाँ पे और साइड यहाँ पे नेगेटिव भी हो सकता है W. ठीक है, please take care of that. Similarly, if you have isochoric process, okay, if you have isochoric process, in isochoric process the volume does not change. Okay, so volume will be equal to 0. जब आपने क्या किया, बॉक्स को ऐसे ही रहने दिया, ठीक है, वॉल्यूम चेंज नहीं होगा बिकॉज नाइदर द बॉक्स इज एक्सपैंडिंग नॉट इट्स वॉल्यूम इज गोइंग डाउन. अच्छा, जब वॉल्यूम यहाँ पे 0 हो जाएगा, सो यहाँ पे वॉल्यूम आपने 0 डाल दिया, सो 0 into P external will be equal to 0. So in this case, the delta U, the change in internal energy, will be only equal to what? It will be only equal to Q. Then we have another case. एक केस जो हमने अभी पढ़ा है, that is free expansion. Okay, so in free expansion what happens? P external is equal to 0. अब P external 0 हो जाएगा, तब भी क्या हो जाएगा आपके पास? P external is equal to 0. Change in volume will be equal to whatever. It will be equal to 0. And that is why the delta U in this case will be also equal to what? Q. Is that clear? Yes or no? Tell me, guys. Correct? Eh? Now, write the next case where the P external is constant. And when P external is constant, we call this, whatever heat exchange happens whenever the P external is constant, we call this heat change as enthalpy, as delta H. Please write this down. When P external is equal to constant, whatever heat change happens here, we call that as delta H, enthalpy, change in enthalpy. अब ये देखेंगे what is delta H. ठीक है, write these things down. These are important results. ठीक है, इसको प्लीज याद रखिएगा. We'll look at this case. Okay, we are going to look at this case now. You will put the topic enthalpy. write the topic enthalpy. Now, enthalpy means, first of all, we know that delta U is equal to change of heat in external pressure. ठीक, sorry, when external pressure is constant. ठीक है, heat when external pressure is constant plus W क्या है आपका, W is still the same minus P external into the change in volume. ठीक है, P external यहाँ पे आपके पास कांस्टेंट है, जीरो नहीं है, याद रखिएगा. सो जैसे हम यहाँ पे इट इज नॉट डेल्टा इज इक्वल टू QP नहीं लिखता है. ओके, नाउ यू कैन राइट व्हाट इज डेल्टा U. इट इज U2 minus U1 which is equal to QP plus minus of P external into V2 minus V1. Now QP will be equal to, QP किसके बराबर हो जाएगा, इसको अगर हम इधर ले आए U2 minus U1. अच्छा, एक काम करते हैं, इस पूरे को ना, लेट अस गेट दिस होल थिंग दैट साइड. तो P एक्सटर्नल आपके पास पॉजिटिव हो जाएगा, सो राइट P एक्सटर्नल इनटू V2 minus V1. ठीक है, और यहाँ पे आपके पास प्लस U2 minus U1. ठीक है, तो QP यहाँ पे आई हैव टेकन दिस P एक्सटर्नल पार्ट into the left hand side. Now this will be equal to P external into V2 minus P external into V1 plus U2 minus U1. Now अब यहाँ पे आपके पास P external into V2 minus P external into V1 plus into U2 plus into minus U1, it will be what, minus U1. अच्छा, अब यहाँ पे आप देखिए, I can write this as now U2 V2 वाले पे एक जगह ले लेते हैं, तो U2 प्लस है P external into V2. Okay, and then we have minus P external V1 minus U1. Correct? Now I'm going to take this as common, U2 plus P external into V2. यहाँ पे दोनों में से माइनस कॉमन ले लिया हमने, तो दिस विल U2 आपका U1 क्या हो जाएगा आपके पास, पॉजिटिव U1, एंड P एक्सटर्नल भी क्या हो जाएगा आपके पास, पॉजिटिव P एक्सटर्नल into V1. QP will be equal to, ये आपका क्या हो गया, U2 minus P external into V2. So this is what, this is heat, this is also heat. So this is heat final minus heat initial. Okay, and what kind of heat is this? This is the kind of heat in which you have the constant pressure, which is known as enthalpy. So QP will be equal to delta H. Okay, so what is enthalpy? Enthalpy कुछ नहीं है, वो आपके पास heat exchange ही है, heat involved at constant pressure. Heat involved at constant pressure is called enthalpy. Okay, heat involved as constant pressure is known as enthalpy. Right, next point. Enthalpy, it is equal to U plus PV. And you write as internal energy, pressure and volume, all are state function अब इन चीजों से ही मिलके क्या बना है, एंथैल्पी बना है। देयरफॉर एंथैल्पी is also state function. देखिए क्यूपी ही आपके पास क्या है, डेल्टा एच है। और यहाँ पे ये देखिए आप, अगर हम क्यूपी को यहाँ पे ऐसे लिखें तो देखिए क्यूपी विल बी इक्वल टू डेल्टा यू, और माइनस पी एक्सटर्नल को उधर ले जाए तो क्या हो जाएगा, प्लस पी एक्सटर्नल प्लस पी डेल्टा वी, दिस इज इक्वल टू योर डेल्टा एच एंथैल्पी। ठीक है, तो जो रिलेशनशिप है डेल्टा यू और एंथैल्पी के बीच में, प्लीज राइट दैट डेल्टा एच is equal to delta U plus P delta V. इतना लिखें, then we are going to prove one more relationship. Let me know if you're done till here. लिख लिया? Okay. Now see, as PV is equal to nRT, we can write pressure into VA is equal to NART. Okay, and similarly pressure at VB is equal to NBRT. A आपके पास इनिशियल मान लीजिए, B आपके पास फाइनल मान लीजिए. Now pressure in volume B minus pressure at volume A state will be equal to NBRT minus NART. Okay, now we can write pressure को हमने यहाँ पे ले लिया, WB minus WA final minus initial is equal to what, NB minus NART. WB minus WA को हम क्या लिख सकते हैं, P into delta V. NB minus NA को क्या लिख सकते हैं, डेल्टा N and subscript में G. Okay, G माने gas, G माने genius नहीं, G माने gas. G means gas because this is for gas law. This is a gas law. Okay, and it is only applicable for the gases, NGRT. And when we are going to substitute this P delta V here, then I will get the new formula of delta H. That is very important. Delta H is equal to delta U plus delta NGRT. Okay, so I will explain what are these terms. Energy, actually energy change at constant pressure, this is delta H, is equal to energy change at constant volume plus Ng क्या है आपके पास, change in number of moles, change in number of moles of gas multiplied by the universal gas constant R into T. Okay, so delta H ये आपके पास क्या एनर्जी का एक टर्म है, डेल्टा U भी एनर्जी का टर्म है, बट what is the difference between delta H and delta U? Delta H is the change at constant pressure, delta U is the change at constant volume. Okay, so Energy change at constant pressure will be equal to energy change at constant volume plus NGRT, delta NGRT. Write this down. देखिए ये बहुत ही इंपॉर्टेंट है। ओके, आपको ऐसे किसी भी इक्वेशन में नहीं दिया रहेगा कि डेल्टा यू इतना है, डेल्टा एच इतना है, आपको ये सारी चीजें लिखे रहेंगे। द एनर्जी चेंज एट कांस्टेंट प्रेशर वाज फाउंड टू बी दिस मच with this reaction at this temperature, calculate the change in energy at constant volume, या फिर वो सीधा बोल देंगे calculate the change in internal energy, or they will give you the change in the internal energy, या फिर they will say that the change in energy at constant volume was found to be this much, यानी कि वो डेल्टा यू बता रहे हैं। Okay, so these terms you have to keep in mind. Write this down, then we'll do a question. Let me know if you are done. Okay, and then you can write starting this question. Reaction of cyanamide with oxygen gas. Reaction of cyanamide with oxygen gas gives out heat at constant volume which is measured to be minus 742.7 kilojoule per mole. Kilojoule per mole, और लिख लीजिए at 298 Kelvin. Calculate the enthalpy change for this reaction. All of you wrote the question, tell me.
Yes, sir.
Okay, ठीक है. Now see here, there are information given. यहाँ पे किस तरह से information दिया उन्होंने, देखिए. Heat at constant volume. Heat at constant volume. जैसे ही आपने देखा ना, किसी भी चेंज का हीट या फिर जो कुछ भी है एट कांस्टेंट वॉल्यूम, दिस विल बी इक्वल टू व्हाट, डेल्टा यू. ठीक है, एट कांस्टेंट वॉल्यूम का मतलब क्या हो गया, डेल्टा यू. दिस इज डेल्टा यू इज इक्वल टू हाउ मच, कितना दिया उन्होंने, माइनस 742.7 किलो जूल पर मोल. ओके, नाउ यू नीड टू आल्सो नो व्हाट इज द रिएक्शन यहाँ पे. ओके, यू नीड टू आल्सो नो व्हाट इज द रिएक्शन यहाँ पे. तो सी हियर, फर्स्ट ऑफ ऑल साइनामाइड, आपके पास शायद वो ना रिएक्शन देंगे ऐसे सवालों में, बिकॉज आई थिंक यू मस्ट नॉट नो व्हाट इज द रिएक्शन यहाँ पे. सो प्लीज राइट द रिएक्शन. Cyanamide is NH2Cl plus O2. Okay. साइनामाइड आपके पास वो देंगे कि सॉलिड होता है and O2 is a gas and it gives you N2 plus CO2 plus H2O. नाइट्रोजन भी आपके पास गैस होगा, CO2 भी आपके पास गैस होगा, and they will give you this complete reaction. Okay, don't worry about this. They will give you complete reaction. जहां पे नहीं देगा वहां पे हम आपको बताएंगे. साइनामाइड के केस में जरूर आपके पास होगा. This is the reaction they have given. Now delta H आपके पास क्या होता है? Delta H is equal to, you will use this delta U plus delta NgRT. Now we know the delta U, we know the temperature, and the constant, that is the universal gas constant, it is equal to 8.314. ठीक है. The main thing that we need to calculate is delta Ng. Delta Ng is equal to number of moles of gas in product minus the number of moles of gas in reactant. Okay. So the number of moles of gas in the product is equal to how much? 1 mole of N2 and 1 mole of carbon dioxide. That means it is equal to what? 2 moles of gas in the product. Minus, in reactant we have 3.3 by 2, that is equal to 1.5 moles. So delta Ng आपके पास कितना जा रहा है? 0.5 mole, or we can also write 1 by 2 mole. Now we have everything. Delta H निकालने के लिए बोला change in enthalpy. So delta H is equal to delta U, that is equal to how much? Minus 742.7 into 10 to the power 3 joules. We'll keep it in joules right now, per mole, plus in delta Ng is half into R is 8.314 into 298. Okay, Kelvin. Your answer will be in terms of joules per mole only. You can calculate this term. Tell me कितना हो रहा है? Calculate this value. सिर्फ इसको calculate कीजिएगा. This is minus 742.700 joules. ठीक है. And you will get this also in terms of joules only, I think. Calculate this term. 298 को अगर हम 300 ले लें, 300 और इसको ले लें 8, so somewhere around it will be what, 1200, somewhere around 1200 आना चाहिए. 0.5 into 8.314 into 298. हाँ, this is coming out to be 1238. ठीक है ना. तो you can also do some approximation. 298 को आप 300 ले लीजिए. 8.314 के यहाँ पे आपने क्या किया? यहाँ पे इंक्रीज किया, तो यहाँ पे थोड़ा सा डिक्रीज कर दीजिए. 8.314 को आपने 8 ले लिया. So 4 and 4 3 are 12. So somewhere around 1200. Okay, so you can take this as 1200 also. जो original answer आ रहा था इसका, this was 1238. Okay, so it is very near to 1200. And when you are going to add this, you will get 742700 minus 1200. This will be minus 741500 joules, which will be equal to minus 741.5 kilojoules. This is the change in enthalpy. Okay, so there are many ways on telling you what is the delta U, है ना? तो सवाल करेंगे जब हम लोग. In the next class we'll do a few more questions, and in that we'll see. So this is one way of telling that you have this value of delta U. Okay, there are other ways of telling what is the value of delta U. एक आपके पास क्या है? You have heat at constant volume. If you see this word, heat at constant volume or energy at constant volume, then all of these things, they tell you that you have been given the delta U. Okay, now there are few more methods of telling you what is the delta U. We'll look at those questions in the next class. Please write this down.